Okay, everybody, please get your foldable, the yellow foldable, and you're going to fold it and glue it onto Toolkit 28 like this is. So you're going to take the words and fold them up and then glue it onto the toolkit so that it looks like this. Okay, so you can pause the video until you get it set up like this. Next, I want you to write the parts of an exponential thing here. We're going to put the coefficient is the number, the big number, if there is one. We have the base, and we have the exponent is the little number here. And you should know what an exponent tells us. An exponent tells us how many times the base is being multiplied by itself. So we're going to look at, you need to know these 5 operations with exponents. Some of the problems we will do will be where we have to multiply with the same base. Okay, so looking at the base, that would mean they both have a base like this. An example of a problem like that, and you could write that, would be 3x to the 4th times 2x to the 3rd power. That's an example of multiplying with the same base. We can see these bases are the same. The coefficients and the exponents do not have to be the same. Okay, I want you to fold open this tab that says multiply with the same base. And so on the outside or the inside cover over here, if you will, copy down that example again. This is multiplying with the same base. Okay, so 3x to the 4th times 2x to the 3rd power. Let's see what happens when I multiply these. So what I'm going to do is I'm going to write out what 3x to the 4th power is. That's the same as 3 and then x multiplied 4 times. Go ahead and write that with me. 3x to the 4th power is the same as 3 times x multiplied by itself 4 times. And then here I am multiplying 2 and x multiplied by itself 3 times. Okay, so I've expanded it. All right, so let's see now what I need to do. I can rearrange the order that I multiply things. That's the commutative property. So I can multiply 3 times 2, and then I can multiply all the x's. So I've got these 4 x's and these 3 x's. Okay, that would be the long way of writing this expression. 3 times 2, of course, gives me 6, and instead of writing out this, I would say that x is being multiplied how many times? X is being multiplied 7 times. Okay, that seems like a lot of work every time that we're going to multiply 2 things. So let's see if we can find a shortcut instead of writing it all out and counting. What is the shortcut that I did with the coefficients to get the 6? Well, I could multiply the coefficients. And what is the shortcut that I do with the exponents? Instead of writing them all out, do I multiply the exponents? No, I add the exponents. Okay, so write that on the inside. If you're multiplying with the same base, you multiply the big numbers, the coefficients, and you add the exponents, not multiply. Okay, so go ahead and write that on the inside cover. Multiply the coefficients and add the exponents. Okay, and then close that tab. And let's look at dividing with the same base, and hopefully you can guess what the shortcut would be here if we divide with the same base. An example of dividing with the same base would be something like this. 10x to the 6th divided by 2x squared. We're dividing and they have the same base. You can only use these rules if they have the same base, if they both have x or both have y or whatever they both have. This is an example of dividing with the same base. Okay, go ahead and open up that flap and we'll copy that on the inside of that flap. So again, we're copying that right here. 10x to the 6th divided by 2x squared. Okay, so let's see what our shortcut would be. I'm going to write this out. This is 10 times x multiplied by itself 6 times over 2, and then x multiplied by itself twice. Okay, so what I'm going to do now is I'm going to do 10 over 2. That's a fraction like I've always used, 10 over 2. And fraction bar means divide, so I can do 10 divided by 2 to get 5, or I could divide both of these by 5 to get 5 over 1, but it's important that you know that that 5 would be on the top. Next, I'm going to see what happens, what I can do if I have x's on the top and bottom. What can I do with the x's? Well, hopefully you know that if I have an x on the top and an x on the bottom, I can cancel it. Why can't I cancel it? Well, because what is x divided by x? X divided by x is 1. X divided by x is 1. Okay, so anytime I do x divided by x, that's just 1, and I'm just multiplying by 1, so it doesn't matter. And then I am left with x multiplied by itself 4 times. So let's see what the shortcut is instead of writing it all out and canceling whenever they have the same number. What can I do with the coefficients? 10 over 2, I could divide or reduce. And what could I do with the exponents? I could subtract. So if you're dividing with the same base, you would either divide or reduce the coefficients and subtract the exponents. Go ahead and write down that that is our rule for dividing with the same base. And it would make sense that these two are kind of opposite of each other. If we multiply with the same base, we multiply coefficients and add exponents. If we divide with the same base, we divide the big numbers and subtract the exponents. Okay, let's take a look next at a power to a power. What that means is I'm raising something to a power, and then I'm raising that again to a power. So an example of that would be 5x to the third power to the third power. So notice, I am raising it to a power and then to another power. 5x to the third power to the third power. Okay, let's rewrite that on the inside, and I'm going to change this to a 3. See if you can think about what I would get for this right here. What would you guess the answer would be if I simplify 5x to the third power to the third power? What am I going to do with the exponent? Okay, well again, I'm going to write it out the long way. What is 5x to the third power? It is 5 times x times x times x. And what does it mean to raise that to the third power? It means I'm going to multiply it by itself and then by itself again. 5 times x times x times x. Again, the commutative property of multiplication tells us that we can reorder this. So I can reorder it as 5 times 5 times 5, and then x multiplied by itself 3 times, again 3 times, and again 3 times. So 5 times 5 times 5, is that 15? No, 5 times 5 is 25, times 5 again is 125, and x is being multiplied 9 times. So let's look at what the shortcut is to get from this to this. Is this 5 affected? Yes, it is. You need to raise a coefficient that's on the inside. You must always raise it to that number. And what's my shortcut with the exponents here? The shortcut to get 3 and 3 to get 9 would be to multiply. Okay, so my shortcut is to raise the coefficient to the power and multiply exponents. Let's go ahead and write that down. Okay. Next, let's look at what the rule is for a zero exponent. Hopefully you already know what anything to the zero power is. An example of a zero exponent problem would be 2 to the 0 power. Okay, and hopefully you know what anything to the 0 power is, but you might not know why. So let's take a look. What I'm going to do is I'm going to do a pattern here on this inside tab. Okay, and I'm going to do 2 to the 3rd power, 2 to the 2nd power, 2 to the 1st power, and 2 to the 0 power. So go ahead and copy this down, and we're going to see if we notice a pattern. Okay, so 2 to the 3rd power would be 2 times 2 times 2. Hopefully you know that that is 8. 2 to the 2nd power, hopefully you know that that is 4. 2 to the 1st power is 2. So what's happening each time I reduce the exponent by 1? This is dividing by 2. This is dividing by 2. So if I keep going, what am I going to keep doing? Dividing by 2. And so that must mean that 2 to the 0 power is 1. Okay, and that works with any number that I have here. Any number that you would use, and any number that you raise to the 0 power is always going to be 1. You could try it in your calculator. Plug in any number that you want, plug it to the, raise it to the 0 power, plug in your phone number if you want, raise it to the 0 power, and you will also get 1. Okay? Here's another reason that anything to the 0 power is 1. Let's say I had something like 2 to the 5th power divided by 2 to the 5th power. What is the shortcut that I would do with my exponents when I am dividing with the same base? I subtract them. That would be 2 to the 0 power. Okay? What happens anytime I have the same number on the top and the bottom of a fraction? It cancels out, because anytime you divide something by itself, you're going to get 1. So that's another reason why anything to the 0 power is 1. Again, anything to the 0 power is 1, and hopefully you understand why. Okay, one more. Let's take a look at a negative exponent. Negative exponent. An example of a negative exponent problem would be 2 to the negative 2 power. So write that on the outside of your foldable. Okay, if we were in class, I would ask to see if anybody knew what the answer to 2 raised to the negative 2 power is. And I would see if there's anybody in here. So what would you answer if I asked you in class what 2 to the negative 2 power is? Okay, think about what your answer would be for 2 to the negative 2 power. I'll give you a hint. It is not negative 4. It is not negative 4. Okay, on the inside, we're going to continue this table some more that we were doing. Continue this pattern, I mean. So remember, I had 2 to the 1st power, 2 to the 0 power. I'm going to keep reducing the exponent by 1. 2 to the negative 1, 2 to the negative 2, 2 to the negative 3. And we're going to keep going down, continuing this pattern. Okay, so we said that 2 to the 1st power was 2. What was anything to the 0 power? 2 to the 0 power is 1. So I'm going to continue this pattern. What am I going to keep doing? Anytime I take away an exponent, I'm doing the opposite of multiplying by 2, so I am dividing by 2. Okay? So, what is 1 divided by 2? 1/2. Okay? And then I'm going to keep going. I'm going to keep dividing that by 2. What is half divided by 2? 1/4. Okay? And then I'm going to keep dividing by 2 again. 1/4 divided by 2. That is 1/8. Okay, the question we were trying to find, though, was that 2 to the negative 2 power. Did any of you think of 1/4? A lot of you probably thought it was -4. Okay, but it is not. It's not -4. 2 to the negative 2 power would be 1/4. So let's see how I can figure out what I need to do with a negative exponent. Well, I would, a negative exponent, and by the way, there can never be a negative exponent in your final answer. Nothing is considered simplified if there is still a negative exponent. So here's what you have to do anytime there is a negative exponent, and not just a negative number, but a negative exponent. So copy this down. If there is a negative exponent, you've got to move what it is attached to across the line and change the sign. Move the negative exponents across the line and change the sign. Move negative exponents, not negative numbers, not any negative number, but negative exponents across the line and change the sign. Only what it is attached to. Okay, so copy that down. All right, pause it if you're not done writing. Let's take a look at what I mean by that. So what would x, you don't need to write this down, but just watch. What would x to the -5th power be? That means I need to move it across the line and change the sign to positive. If there's nothing on the top, what am I going to put? A 1. Okay? But what if there was a negative exponent on the bottom? What do you think you would do with it? Well, yeah, you would move it to the top. It would be x squared. Okay? What if I had 5y to the -2 power? I said move what it is attached to. Is this -2 attached to this 5? No, it's not. So I would move the negative exponent. It would be y to the +2 on the bottom, and the 5 would stay on top. Okay, we're going to use those 5 exponent rules to simplify all of these here. Okay, example 1. Let's see, which rule would this fall under? I am multiplying with the same base. Okay, so what do I need to do if I'm multiplying with the same base? I need to add exponents. 4 plus 2 plus -3. 4 plus 2 gives me 6 minus 3. So this is just x to the 3rd. Again, if you are multiplying with the same base, you add exponents. You multiply coefficients. So you could do 1 times 1 times 1. Okay. Again, right here, I'm going to multiply coefficients. 4 times -2. That gives me -8. And I'm going to add exponents. So looking at my x's, this x does not have an exponent here. If anytime there's not an exponent, I want you to put a 1. And I need to add the exponents. X to the 1st times x to the 2nd would be x to the 3rd. Y to the 3rd times y to the 5th would be y to the 8th. Again, I'm going to multiply coefficients and add exponents anytime I am multiplying. Okay. Looking at number 3, I'm going to do 16 over 4 the same way I have always done 16 over 4. 16 divided by 4 is going to be 4 on the top. Okay? And then I'm going to look at s to the third minus s to the second. I need to subtract. 3 subtract 2 would be s to the first. And then t to the ninth divided by t to the sixth. I need to subtract exponents. 9 subtract 6 would be t to the third. And anytime I have the same thing on the top and the bottom, I'm going to cancel it out. Okay, I'm not going to put a u. I could do times 1 if I want, but I don't really need to. So that is my final answer. When you are dividing with the same base, we subtract exponents. Divide or reduce coefficients and subtract exponents. Okay, now looking at number 4, we're going to do the same thing. We're going to divide or reduce the coefficients. 3 over 9 is going to reduce to 1/3, just like it always has. Okay, anytime there is not an exponent, I need to put a 1 coefficient. So I need to subtract my exponents. So I need to do 5 subtract 1. 5 subtract 1 is going to give me x to the fourth. And think about if we had 5 x's on the top and 1 x on the bottom, there are 4 more on the top. Now looking at this, if we had 3 y's on the top and we had 8 y's on the bottom, okay, we subtract these, and what am I left with? I am left with 5 more y's on the bottom. So think about where there would be more, where the leftovers would be. Okay, how else could you do that using the shortcut? I could do 3 subtract 8, and that gives me y to the negative 5th power, okay, which tells me if it's a negative, that tells me it's on the bottom. So there were 4 more x's on the top here, and there were 5 more y's on the bottom here. So look at where the leftovers would be if you canceled them out. Okay, so as my final answer, I would write this as x to the fourth over 3y to the fifth. It's not wrong if you have that 1 there. Okay, number 5. Same thing, the 4, there's really nothing to do with that 4 there. Okay, let's look at our a's. I have a to the second over a to the 7th. Okay, so I could do 2 subtract 7. 2 subtract 7 is going to give me what? It's going to give me negative 5, which tells me that it's a to the 5th on the bottom. Okay, if you have 2 a's on the top and 7 a's on the bottom and 2 of them cancel out, you have 5 left over. Okay, anytime there's not an exponent, remember please put a 1. Okay, so I have b to the first over b to the 5th. Where are there more b's? There are 4 more b's on the bottom. 1 subtract 5 gives me negative 4. That tells me they're on the bottom. If there is nothing on the top, we're going to put a 1. Okay, number 6, we talked about a power to a power. You need to distribute to everything on the inside, including this 2, and you need to multiply. Okay, so that gives me 2 to the 3rd power, m to the 3rd power, n to the 3rd power, and o to the 9th to the 3rd power. Okay, I give everything that 3 exponent. And anytime there is a exponent inside and outside parentheses, I need to multiply. So this gives me 2 times 2 times 2. M to the 3rd power gives me m to the 9th, n to the 3rd. O to the 9th to the 3rd power gives me o to the 27th power. Okay, same thing for number 7. I'm going to distribute this 2 exponent to everything, including the 8. So that would be 8 to the second, x to the 4th to the second power, and y to the second power. And if we did put an exponent there, it would be a 1, right? And we would be multiplying 1 times 2. What is 8 squared? 64. Make sure you're squaring numbers and not multiplying them. Not 8 times 2, but 8 to the second power. X to the 4th to the second power, I need to multiply, and y to the second. Now let's look at some of these negative exponents. What's our rule for negative exponents? Negative exponents move across the line and change the sign. So I need to take this x to the negative 2 power, move it across the line and change the sign. I need to take the z to the negative 9th power, move it across the line and change the sign. If it's negative on the top, it moves to the bottom and becomes positive. A negative exponent on the bottom moves to the top and becomes positive. Now remember, that's just a rule for negative exponents, not negative numbers in general. Okay, so the 5 I'm not going to do anything with. The y to the 7th I'm not going to do anything with. But this z to the negative 9th would move to the top and become z to the positive 9th. X to the negative 2 on the top would be an x to the positive 2 on the bottom. So negative exponents, we just move across the line and change the sign. Negative on the bottom moves to the top. Negative exponents on the top move to the bottom, and only move what it is attached to. Okay, number 9 has a lot of steps. I'm going to reduce the 2 over 8. Treat the 2 over 8 like I always have. That's going to be 1/4. Okay, now let's look at these h's. I've got h to the negative 5th over h to the 2nd. There's a couple ways you can look at that. I could subtract. Negative 5 subtract 2. What is negative 5 subtract 2? Negative 7. That tells me that that's going to be a h to the positive 7 on the bottom. The other way you could have done that is taken this negative 5, moved it to the bottom, and know that there would be 7 h's being multiplied on the bottom now. Okay, so you could subtract 6, subtract negative 2, or I could take this negative 2 and move it to the top. And then how many i's are being multiplied on the top? I know that there are 8 i's being multiplied on the top now. And same thing, 6 subtract negative 2 is 8. Okay, and then the j's, j to the 5 subtract 8. I could subtract 5 subtract 8. If I have 5 j's multiplied on the top and 8 on the bottom, where are there more? There are 3 more on the bottom. So I would write my final answer without that 1, I to the 8th over 4, h to the 7th, j to the 3rd. Okay, let's look at 5 to the negative 2 power. We said a negative exponent moves across the line and change the sign. Right now there's no fraction line, it's technically over 1. Okay, so this would move to the bottom. It would be 1 over 5 squared. And what is 5 squared? 5 squared is 25. Okay, so 1 over 25. And when it's just numbers, you could check it in the calculator. If I do 5 to the negative 2 power, it gives me 0.04. That is the same as 1 over 25. Okay, so think about raising 5 to the 2nd power would be multiplying by 5 several times. 5 to the negative 2nd power is pretty much dividing by 5 twice. Okay, When I have a negative 3 exponent on the bottom, that means it needs to move to the top. And it would be 3 to the positive 3 on the top, which is 3 times 3 times 3, or 27. Okay, you could check that on the calculator. 1 over 3 to the negative 3 power is 27. Okay, 2 to the negative 3 power, since it's a negative, it would move to the bottom. 1 over 2 to the third power, or 1 over 2 times 2 times 2. That gives me 1 over 8. Okay, now, this is a tricky one. Negative exponent means it needs to move to the bottom. Okay, when I move it to the bottom, this is still going to be a negative 4, but when I move, negative exponents become positive. There's nothing on the top, so I'm going to put a 1. Okay, negative exponents move across the line and change the sign. Negative numbers we do not need to move, and they do not become positive or negative, just regular negative numbers. Negative exponents do. So this is 1 over negative 4 times negative 4 times negative 4. Okay. Negative 4 times negative 4 would give me a positive 16. That gives me a negative 64. Overall, that gives me 1 over negative 64, or negative 1 over 64. Okay, a couple more. Number 14. I notice a 0 exponent stands out to me, and anything being raised to the 0 power I know is what? Anything raised to the 0 power is just 1. Okay, so what does that mean? That means that all of this is just 1 because it's being raised to the 0 power. All of this is 1 because it's being raised to the 0 power. What does multiplying by 1 do? Yeah, not too much. So really we can just kind of cancel that out. Only things that are being raised to the 0 power. Not this entire question is not being raised to the 0 power, just this. Okay? Next, I'm going to distribute this negative 2 exponent to everything on the inside. So I've got 2 to the negative 2 power, x to the negative 4th to the negative 2 power, y to the negative 2 power, and z to the 5th to the negative 2 power. Okay? What do I do for a power to a power? Anytime there's a number inside and outside, I need to multiply. So this would be x to the 8th. Okay, and this would be z to the negative 10th. A power to a power means I need to multiply. So I've got 2 to the negative 2 power, x to the 8th, y to the negative 2 power, z to the negative 10th. Okay, then what do I need to do? I need to take any negative exponents and move them across the line and change the sign. If there's no fraction yet, that means it needs to move to the bottom. Okay, so what do I have? I have x to the 8th stays on the top. This 2 to the negative 2 would be 2 to the positive 2 on the bottom. Y to the positive 2 on the bottom. Z to the positive 10 on the bottom. Okay, and then I could do what 2 squared is, which is 4. Y squared z to the 10th. Okay, let's look at number 15. There's 2 ways you could do this. Okay, one way is I could just take negative exponents, move it across the line, change the sign. Okay, so this t to the negative 3rd would be a t to the positive 3rd on the top. T to the negative 9th on the top would be a t to the positive 9 on the bottom. Okay, And then when I look at this, if there's 3 t's on top, 9 t's on the bottom, where are there more and how many? There are 6 more on the bottom. And if there's nothing on the top, I put a 1. That's one way you could do this. Let's look at another way you could have done this. We could use our shortcut, which is to subtract. -9 subtract -3. Okay, what is -9 subtract -3? Is t to the -6 power. And you cannot leave a negative exponent in your answer. If you look at all of our answers, none of them have any negative exponents left over. If there's a negative exponent in the answer, you're not done. You cannot leave a negative exponent in an answer ever. Lastly, number 16, there's 2 ways you could do this. You could simplify inside first and then distribute, or you could distribute and then simplify. Okay, either way is fine. Let's say I did distribute everything to everything on the inside. That gives me 2 squared, x to the 7th squared, 6 squared, x to the 3rd squared. Okay, anytime I have a power to a power, I need to multiply. So 2 squared gives me 4. This gives me x to the 14th. Power to a power means I multiply. 6 squared is 36. And multiply x to the 6th. Okay. 4 over 36. I could divide both of those by 4 to get 1/9. And then 14 subtract 6. If I'm dividing with the same base, 14 subtract 6, and that gives me x to the 8th, because there's 8 more x's being multiplied on the top than on the bottom. So as my final answer, I would write it as x to the 8th over 9. Okay, these are kind of tricky because there's multiple ways to solve a lot of these, but you're using those same 5 rules that we talked about.